question 13. A is the point -6, 7, B is the point -2, 7, and C is the point 1, 1. So looking at question A, quadrilateral ABCD has rotational symmetry around the midpoint of AC. Find the coordinates of D. Alright, so when you say something has rotational symmetry, it means when they rotate, you should end up with the same thing on the other side. And the center should be midpoint of AC. Alright? So the way I can explain it is, let's look at a rough sketch here. So let's say this is the quadrilateral. And then when you turn it, when you flip it, it should still end up like this. So this is the midpoint and this is the midpoint. What does this mean? This means that the distance here between these two guys is the same distance as the midpoint to our actually our imaginary point D. Okay, so how do we find D now that we kind of understand what rotational symmetry will look like? Okay, D will be somewhere here. First, we must find the midpoint of AC. How to find the midpoint? So let's look at x-axis wise, we're looking at 1 and -6. So 1 minus -6, you're looking at 7, and midpoint should be divided by 2, 7 over 2, 3.5. All right. Next, let's look at our height. Y will be 7 minus 1. Okay, sorry, this looks like a 7 is 1. 7 minus 1 over 2, you will have 6 over 2 over 3. Okay, so now that we know that, we also know that the distance here should be the same as distance here, right? So let's find a distance here to the midpoint. All right, so from B to midpoint, we have, okay, because we want to find the distance here, right? We have -2 minus. All right, so for a for your information, right? This is an absolute value. So when we are looking at, all right, let me just dismiss the list. Okay, so you're looking at 3.5 here. So 1 minus 3.5, you're looking at -2.5, and your height is 3. So 1 plus 3 is 4. So from the midpoint, we're looking at -2 minus -2.5 over, okay, there's no over. Okay, so we're looking at this place and this x and y. All right, so then that will be -2 minus minus plus 2.5. Oh my goodness. 5, and that will be 0.5 of a difference. And y, let's look at the y difference. All right, 7 and 4. So this is a little more straightforward. 7 minus 4, you're looking at 3. All right, so now what do you have? You have a difference of 0.5 and a difference of y. So to make it into D, we have to do the same difference. So what do? You minus what? The x difference again, and you minus the y difference from the midpoint this time. So find D from midpoint, right? So first, what do? X, you will get our number here, which is, oh my goodness, sorry, I have made a mistake. your x should be negative 2.5 and your y should be 4. All right, so negative 2.5 minus 0.5 yet again, okay? So this will get you to 3. So your coordinate for dx should be 3. And now for your dy, 4 minus what? 4 minus 3, okay? So 4 minus 3 equals to 1. So your coordinate for d should be negative 2.5 minus 0.5 is negative, negative 3 and 1. All right, now let's look at, okay, this is your coordinate d. Let's look at b. Find the equation of AB. Okay, AB. AB. You see that the y is the same. So what can you assume? This is a horizontal straight line. Alright? So when it's a horizontal straight line, all you have to do is show me where it is on the y-axis. So part 2 is part 1 is quite easy. Y equals to where are they the same? 7, right? So y equals to 7. All right, and AD. All right, AD. Our little. Okay, let's put in our D. Our D is negative 3 and 1. So that will give, okay, our point A is 6, negative 6, 7, and B will be negative 3, 1. How to find equation of a line when it's not a vertical straight line or a horizontal straight line? Remember, your y equals to mx plus c. A reminder, m equals to gradient, c equals to, your c will equals to intercept, y-intercept. All right. So let's see if they're gonna give us any clue whether it goes straight right into the y-axis. No, this line does not penetrate the y-axis on the graph. So we will have to figure it out the algebraic way. So first, what can we do? We can find our gradient. And if you don't remember, to find your gradient is y2 minus y1, x2 minus x1. Okay, your gradient should always be, your second set will always be the one towards the right. And if you look at our little AD line here, it is going down. That means our gradient should come out as negative. All right. Our y2 will be 1 and our y1 will be 7. So this will be our y2, y1, okay, and then same go for x1 and x2. So x1 again, y1, okay, x1 will be x2 minus negative 6. All right, let's look at this question. So this will be negative 6 minus 3 plus 6, because negative, you plus 6, all right? So it will be negative 6 over 3. Then there will be a negative 2. Here's your gradient. And to find your C, let's just sub in one of the number, which I'm going to choose negative 3 and 1. All right? So that's your point B. I mean, D, my goodness. Okay, A, D. Okay, negative 3 and 1. So y equals to 1, x equals to negative 3, m equals to negative 2. That will be, okay, 1, 2, negative 2, negative 3, plus c. So what's going on here? Negative 2 times negative 3. You get 6 and 1 plus c. All right, so c will be minus 5, 1 minus 6 equals to c. C is negative 5. So what should your equation finally be? Y equals to your gradient, negative 2, x plus, is it plus? No, because your y-intercept is a negative, right? So minus 5. All right. Last but not least, find the coordinate of the point where AD cuts the axis. Okay. So this might be my mistake, cuts the x-axis. So when does it cut the x-axis? When y equals to 0. So when y equals to 0, then you will cut the x-axis. So very simple. Again, we employ the equation we found just now. Okay? Our equation just now was y negative 2x minus 5. You want to see where it cuts x-axis? Y equals to 0. So 0 equals to negative 2x minus 5. Okay, 5 equals to negative 2x. X equals to negative 5 over 2. So what do you have now? You have your coordinate where it cuts, negative 5 over 2, and y-axis 0. All right.